In this video I want to talk a little bit about the graphs of sine and cosine, and I hope you recall what they look like in general. Sine starts at the origin, 0, 0. It has a maximum value of 1 if we don't do any adjusting, a minimum value of -1. It has a period, if we can see one period here, I guess from here to here, its period is 2 pi if again if you don't adjust it, so we'll make one full cycle, or in one period, in 2 pi. Cosine is similar in that its maximum is still 1, its minimum is still -1. The biggest difference is that it starts at 1, as opposed to sine, which starts at the origin. It starts at its highest point and then decreases. The period from top to top is still 2 pi. So with those basics, we're going to try a little bit different graphing. So in this case, the amplitude. Well, the amplitude is how high the function goes from its middle. We can always get that by looking at the lead coefficient, so the amplitude is 2. The period. To calculate the period, we always do 2 pi divided by what we call b. b is simply the coefficient. So in our case, the coefficient would just be 1. So 2 pi over 1, of course, is just 2 pi. The vertical shift, of course, is this number at the end, so we've been shifted up 5. And in these particular examples, I have not done any phase shifting. I'll get down to that in my next couple examples. So, to start the graph here, I always start with the vertical shift, so, because the graph is small, maybe I'll just say, it's 5. That's the center. From there, the amplitude is 2, so it's going to go up to 7 and down to 3. It's sine, so it's going to start at its middle. It's going to start here, go up, back down, that, and remember, it would just continue on from there. But I'm going to label this one period would be 2 pi. Next example, the amplitude. Well, this one, the amplitude, we can see the 3, it looks negative. The negative is not part of the amplitude. The negative simply states that there's a reflection. We'll get back to that, but the amplitude is just 3. The period, I always do 2 pi over b. In this case, b is 2. 2 pi over 2 is just pi. And the vertical shift is up 1 unit. So 1. The amplitude's 3. So we're going to go up to 4 and down to -2. Now it's cosine, so normally that would start at the top, but in this case, since it's negative, it's actually going to start at the bottom. So cosine's going to start here, up, down, and of course it will continue from there. But let's label that that's got to be pi, since that was one period. Alright, last, we've got an amplitude of 5, period 2 pi over b, which is pi, so that becomes just 2. Vertical shift is going to be down 4 units. Okay. So -4 will be our center. Since the amplitude is 5, it's going to go all the way up to 1, all the way down to -9. It's cosine. It's not being multiplied by anything in this case. It's cosine. It's going to start at the top, down, back up, and then, as I said, continue on. We'll just put in a label for one period. There we are. I wanted to do a couple here with phase shifting, so let's start the same. The amplitude is still going to be 2. It's still that lead coefficient, so 2 is 2. Period is still 2 pi over the coefficient of x, is 2. So this will just be pi. Vertical shift is plus 2. The phase shift. Now the phase shift comes from what's in the parentheses here. So x minus pi. And like all the other shifting you did, it always works the opposite. So in this case, because it's subtracting pi, it's actually going to move to the right pi. So like plus pi. I usually even make a little arrow. I just say to the right pi units. Okay. So let's do a little labeling. The vertical shift is 2, so 2. Now it's going to go up to 4 and down to 0 because of the amplitude. It's going to start at pi, and because it's starting at pi, remember that's the phase shift, that's where it's going to start, and the period's pi, actually it's not going to look any different than a normal sine wave because we shifted it basically onto itself. But let me also label where it's going to end, so at 2 pi. So it's a sine curve. It starts at its center. It's up, down, back. But it actually, because it shifted onto itself, it shouldn't look so wavy there, but I'm trying to make it dotted. It would look something like that. Alright, last example. In this one, the amplitude is 4. Period, we always do 2 pi divided by b, so 3. So our period is going to be 2 pi over 3. Vertical shift is up 1 unit. The phase shift, since we're adding pi over 2, it's going to be to the left pi over 2. So let's put in everything here. We're up 1 unit. Got an amplitude of 4, so it's going to go up to 5, down to -3. Since it's been shifted back pi over 2, I put that in here, negative pi over 2. Now the one thing is, that we had to do up here is we had to figure out where it ended. It was easy because we started at pi, that was our shift, the period was pi, so we said, well, if it starts at pi and the period's pi, it ends at 2 pi. That's not as easy here because it started at negative pi over 2 and one period is 2 pi over 3. So I like to add those together so that I can see where's it going to end up. Here's where it started. Here's one period. So where should I mark on my graph that it ends? Okay? So, we maybe get a common denominator of probably 6. So multiplying this one by 3, we get negative 3 pi over 6. Multiplying this one by 2, we get 4 pi over 6. So it ends at pi over 6. And again, let me just explain what I did there. I said this is where it starts, and I'm adding one period to see where it ends. So this is its ending spot. I can label that. I can put pi over 6 right here. Its cosine, I know where it starts. Start at its highest point, come down, back up, and continue.